So hey everyone, in the last video we had understood how do we construct a graph. In this video we are going to understand how do we traverse a graph. Okay, so let's say this is a graph and I just want to put all of the nodes into a particular array. So basically I want to traverse all of it. So I can traverse in many ways. I can go from 0 1 2 3 4, or I can go in a horizontal way. So that is 0 1 3 4 and then 2. Okay, so there are two types of traversal, just as we saw in the tree video as well. So that is breadth first traversal and depth first traversal. Okay, so the same applies for graphs as well. So how do we traverse it, whether we go in the breadth ways or in the depth ways, where like the horizontal or the vertical way. Okay, so basically there are two ways, as I told. One is the breadth first and then the depth first. Okay, so I'm just going to give a comparison between these two. So let's start with the depth first. Okay, so here we just need to consider any one vertex to start with. Okay, unlike trees, we used to start with a root node, right? So here we do not have any kind of root node, so we can just start with any kind of vertex or node. So I'm just going to start from 0. Okay, so here we use the stack data structure, as I told you, whereas for breadth first we are going to use a queue data structure. Okay, so the same which we did even for trees as well. So this is the thing which you must remember. So when you are doing depth first traversal, we need to use a stack, and for the breadth first we need to use a queue. Okay, so let's initialize the stack and set this to an empty array, and also let's create another array to store all the visited nodes. So we can call it result and also set this to an empty array. Okay, so as I told, we need to start from any one of the vertex. So let's start from 0 and we need to add that to the stack. Okay, so now we need to check the neighbors of 0 or the adjacent nodes from 0. Okay, so we have 3 adjacent nodes, so we can go from any one of them. Okay, so let's say we want to go from 1. Okay, so we add 1 to the stack and then we again check the neighbors. Okay, and we just need to go as deep as possible. So we can go from 1, then we add 2, and here we have two choices, either we can go from 3 or 4. So let's go to 3, and after 3 it is going again back to 0, but 0 has already been visited. So you see that we have 0 within our stack, so we add all of these elements to the results array. So 0 1 2 and then 3. Okay, so now we need to pop 3 of the stack. Okay, because it has no more unvisited nodes. Okay, so we have visited all of them, so we pop 3 of the stack, and then we go back to 2 and we see that from 2 do we have any unvisited nodes. So we have that 4 is unvisited, so that's also not there within our result array. So we add that to the stack, and we need to check the unvisited neighbors of 4. Okay, so you see that there is only 0 and 2 which are already there within our results array, right? So we again pop 4 of the stack. Okay, so again 2 is also all we have visited, again we pop 2 of the stack, again 1 the neighbors are 0 and 2 which are already there within our result array, so we pop 1 also of the stack. So we keep doing the same unless the stack is empty. Okay, so I forgot to add 4 to the result array. Okay, so while we were checking for the 4, okay, so as long as the stack is empty, we just need to keep doing the same. Okay, so this is how we can traverse a graph. So we see that the result comes from 0 1 2 3 and 4. So 0 1 2 3 and then 4. Okay, so what we are doing here is we are going as deep as possible and checking are there any unvisited nodes. So if there is no, then we just pop that off and go to the next branch. Okay, so then we see what are the unvisited nodes from there on, and then we keep popping off the stack unless we find that the stack is empty. Okay, so I hope that's clear. So this is how you traverse a given graph. So let's now understand how do we traverse a particular graph using breadth first. So over here, as I told, we need to use a queue data structure. So we need to initialize a queue over here and also the result. So basically this will hold all the visited nodes. Okay, so as I told, within queue this follows the FIFO principle, that is first in and first out. Okay, so whereas for stack we use a LIFO principle, so the last one to be in is the first one to go out. Okay, so here we need to again start with any one of the nodes. So let's start with 0. So we need to add 0 to the result array, and then we need to dequeue this. Okay, so once this is done, and we need to check the neighbors of this particular 0. Okay, so that is 1 3 and 4. So we need to add them to the queue. So we add 1 3 and 4. Okay, so since this is a queue, it will go from reverse order. So first one, you can think of a person who is standing in a line. So 1 is first, and then comes 3, and then comes 4. Okay, so this is like a queue, and then once we find that there are no more adjacent elements from 0, so we just need to dequeue them one by one. Okay, so we can do that from we can dequeue 1. So now we need to check, are there any unvisited nodes from this particular node that we dequeued, right? So 1 is the one which we dequeued. So is there any unvisited nodes? Yes, there is. That is node number 2. So we add that to the queue. Okay, so it should not come over here. So since this is not a stack, we add 2 over here. Okay, so before 4, and then we check if there is any unvisited nodes after 2. Then there is 4, right? So 4 is already there within our queue, so we don't add that again to the queue. Okay, so now we just need to dequeue 3 over here. So 3 is being dequeued, and we check, are there any unvisited nodes from 3? So 0 and 2 are already visited, so which is already there within our result array, and 2 is there already within our queue. Okay, so we there are no unvisited nodes, so then we dequeue 3 and then add them to the result, and then we have 4 over here, and check if there is any unvisited nodes. So everything are visited. Again we add 4 to the result and dequeue 4. Okay, so the only thing left is 2 within our queue, right? So 2 is over here, and are there any unvisited nodes? There's no, right? Everything are been visited. So finally we dequeue the last element within our queue and then add them to the result array, unless our queue is now empty. Okay, so we see that this is the traversal that we have done in a horizontal way, that is breadth first. So we start from 0, 1, 3, 4 and then 2. Okay, so you can just think of this as levels. So this is the top level, this is the second level, and this is the third level. So we traverse all the elements from the top level, so that is 0 over here, and then 1, 3, 4, that is the second level, and then the third level we have 2 over here. Okay, so this is how you can traverse a given graph horizontally or in a breadth first manner. So these are the traversal techniques which you can implement on graphs. Okay, so this is almost similar to trees as well, but there we had root elements, but here we do not have root, so we just consider them any one of the node or vertex and then start traversing from there on. Okay, let's understand how can we traverse a particular graph inside JavaScript. So let us traverse this particular graph which I have shown over here. Okay, so I have used numbers this time, so you can use any data type if you want. So let us go ahead and construct this particular graph. So we have already constructed this particular graph class. Okay, so we have methods like add vertex, add edge, and if you also want to remove an edge and vertex. Okay, and also a method to print the adjacency list. So let us use these methods that are defined within the graph class, and let's get started one by one. So I'm going to add the vertex of 1 and go all the way up to 6. So I have added the 6 vertices to this graph. So let us now connect them whichever they have a relationship with. So let's connect 1 to 2, and then from 1 to 3. Okay, so you get the idea, right? So you can just do it by yourself if you want. So I'm going to connect 2 to 4. Okay, and do the rest. So we have now added the edges as well. So there is a connection between 1 and 2, 1 and 3, then 2 to 4, and then 3 to 5. Okay, and 3 to 4 as well, and 5 to 6 and 6 to 4. Okay, so this completes the entire graph. So if you want, you can verify by printing the adjacent list as well. So we can now go ahead and create a function to traverse the graph using depth first. Okay, so let's call this function depth first traversal. Okay, so this is going to receive 2 arguments. One is the graph itself, and then we are going to expect the starting vertex, okay, which is going to be the starting point of our traversal. So let's say starting vertex, and inside this we are just going to first check if the starting vertex even exists. Okay, so if it doesn't exist, then we just want to return an empty array. Okay, so let's check if putting a not operator, so graph dot adjacency list at the starting vertex, if that doesn't exist, then we are going to return an empty array. Okay, so after this, let's create a particular variable to store the visited vertices within a visited object like this, and also let's initialize a stack which is just going to be an empty array. Okay, and let's now first push the starting vertex and also make the starting vertex to be visited. Okay, so let's first push the starting vertex to the stack. Okay, and then we want to add that to the visited object as well. So visited at starting vertex, and then set that to a truthy value. okay, and now we just want to run a while loop. Okay, so while the stack is not empty, okay, so while we are keeping a track of all the visited vertices within the stack, okay, and we are just going to loop across every single item within the stack and just keep pushing within our results array, okay, just as I explained. So let's also create that results variable or result and initialize that to an empty array. So let's run that loop, which is going to be a while loop, and check if the stack dot length is has some value. So as long as there are items within our stack, we run this loop. So let's pop the last element within the stack and store within a variable called current vertex. Okay, so stack dot pop, and for this current vertex we push it to the results array. Okay, so result dot push the current vertex. Okay, so now we just need to account for the edges as well. Okay, so whatever the edges this particular vertex has, so for example we are considering 1 as a vertex and it has edges for vertex 2 and vertex 3, right? So we also need to counter that. So this is our adjacency list, right? So for every vertex that we have, we check its neighbors. So basically we can call this as neighbors, so where it has establishes connection to the different vertices. So we check this current vertices are already been visited or not. So if they are not visited, then we add them to this visited array or this object. Okay, and then finally we add them to the results array as well. So if they are already visited, then we don't do anything, so we just go to the next iteration. So let's do graph dot adjacency list. Okay, and then at the current vertex. Okay, so basically these are the elements, right, for the current vertex. Okay, for in this case it's 1. So these are the two items within this particular array. So we just loop across it. So we are using the for each, and for every as I told, we can call this neighbor. Then we can check if the neighbor has already been visited. So if not visited at neighbor, okay, so we are checking with this within this particular object, and after that if it is not visited, then we add that, okay, to that particular object of neighbor. So this spelling should be neighbor, okay, and set that to true. Okay, and then finally push that to the stack. So stack dot push the neighbor. So that's it. Finally we return the results array. Alright, so let's now test this out. I think everything is good. Maybe the neighbor spelling, I just spelled this wrong. Doesn't matter as long as the variable name is the same. So let's go ahead and run this particular function, that is depth first traversal, and then print our result. Okay, so let's console log depth first traversal and pass in the graph and the starting vertex. Okay, so in this case let's say 1. All right, so once I save this and just try to see, so there we go, we get our traversal over here. So it goes from 1, 3, 4, 6, 5 and then 2. Okay, so first it goes from the left side and then traverses all the nodes over there, and then finally on the right side. Okay, so this is what is the result. So for the depth first, so it is going as deep as it can, and then once it finds that there are no more elements within the stack, so we have visited all the nodes on the left, so then it moves to the right. Okay, so this is how we implement depth first search, depth first traversal within a graph. All right, so let's now understand how to do the breadth first traversal. So let's create a function for the breadth first traversal. So breadth first traversal. Alright, and this is as well going to take in the graph and the current or the starting vertex. Here we are going to use the as I told, the queue data structure. Okay, so for queue also we can just use array itself, but we can use the shift method to access the last or the first element within the array. Okay, so let us create those 3 variables. One is to keep a track of all the visited vertices, so visited, and set this equal to, and this time I'm going to use a set, okay, instead of an object, just for a change. And how you can also use sets, okay, within any kind of data structure which you want to create. We can access methods like add, has, all of that. Okay, so that's why we can use a set within this case. So let's also initialize the result array and also the queue. Okay, so also the queue is going to be an empty array. Okay, and now let's run a or before that, let's push the starting vertex to the queue and to the visited set as well. So queue dot push the starting vertex and visited dot add. Okay, so since this is a set, it has a method called add and add the starting vertex. Okay, so now let's run a while, and while queue dot length. Okay, as long as there are elements within our queue, then we are going to run this loop. So first we are going to grab the current vertex and set this to queue dot shift this time. Okay, so shift is a method which is used to access the first element within a given array, okay, or any array for that matter. So this will grab the first element and we push that to the result array. Okay, so result dot push and then the current vertex. Okay, so this follows the FIFO principle. So the first one to go in is the first one to go out. Okay, so you can just consider queue like you know, the people standing in a line, so in that way. Okay, so let's now loop across all the vertices of the current vertex. Okay, so whatever the neighbors it has. So now let's check the neighbors of this current vertex to the other vertices where it has connected, and we check that if it is already there within our queue, then we add it to the queue and also to the result array. So if it is not there in the queue, we just you know, just skip that particular value, okay, or the neighbor, which is because that's already been added to the result array, right? So we do not want to add that again. So let's get that from graph dot adjacency list. So at the current vertex, okay, so which is an array, right? So we can just use for each, and for every neighbor we just check if the neighbor is already visited. So we can do if not visited, so which is a set, right? We can use a has method on that and check for the neighbor if it exists. So if it doesn't exist, so we push that to the queue. So queue dot push the neighbor. Okay, and also we add that to the visited. Okay, so dot add neighbor. All right, so let's finally return the result after the loop. Okay, so I return. All right, let's now console log this particular result that it returns us by this function breadth first traversal. So let's console log breadth first traversal and pass in the graph as well as the starting vertex. Okay, so the starting vertex is again 1, and now let's check. Okay, so we get 1 2 3 4 5 6. Okay, so the order of this execution is starting from the first level. Okay, so the first level is like 1 2, and then it goes to the second level, so it goes horizontally and check for every vertex, and then it goes from 3 to 4 and then 5 to 6. Okay, so that's what we have within the result array. So that is all for this graph data structure. If you have any questions, please let me know in the comments, so I'll just try to answer them. And I know this might, if it seems a little bit confusing, so you might just want to go across every single line of code and just analyze what exactly is happening at that point in time, and then just try to analyze. Okay, so that's the trait of any good developer, to analyze every point in code and then try to understand and just brainstorm what exactly is happening. So this is all. Thanks so much for watching. Make sure to subscribe, and I'll see you guys in the next video.